Hey guys, in the previous video we talked about a stacks and queues problem, which was finding the maximum rectangular area in a histogram. And in this video, let's get back to a dynamic programming playlist. And in this one, we're going to talk about the palindromic splits of a given text. So welcome guys, my name is Amartya, you're watching Developedia, and to be a part of this family, please subscribe. Alright guys, now let's take a look at the problem statement first. So the thing is, you're given a text and you're asked to split this text in such a way that all the parts are palindromes by themselves. And your task is to find the minimum number of such splits required. So for example, if you're given this string AABABA, then you can split the string in this manner. And in that case, the number of splits required are 5, 1, 2, 3, 4, and 5. If you split it this way, you can see that all the parts are palindrome by themselves. This is AA, this is BAB, and this is A. 3 are palindrome by themselves, and the number of splits are here too. And if you split like this, then you're going to find that all the parts are palindromes by themselves as well, because this is A, and this is ABABA, both of which are palindromes by themselves, but in this case the number of splits required is 1. And you take the minimum out of them, and the minimum number of splits you're getting in this problem is 1. So your task is to find this minimum number of splits. Now pause the video right here and think about the solution, and when you're ready, keep watching the video for a solution. Alright guys, now let's take a look at the problem. So the problem is that if you have a string and you're asked to find the number of splits, the minimum number of splits required from the starting index to the end index, so what you're going to do is that you're going to make this string as a global variable, and you're going to deal only with indices. So you're having a from index where you put the start index of this string, and you put the to index, which is the end index of this string. So in this example, in the driver code, you're going to write get splits of 0, 5 for this particular example. Now, let's say in this example, you're having get splits of 1 to 4. What it means is that it represents this substring that starts from 1 and ends at index 4. Now, what is this subproblem? The subproblem is getting the splits of something, some string, which has a starting index greater than this start index, the from index mentioned in here, and which has a to index which is lesser than this. So therefore you can write that I and j here are basically ranging from 0 to to index minus from index. What it means is that you're going to use any information that lies within this 1 and 4 index. What it means is that if you're asked to find, if your given problem in here is finding the get splits of 1 to 4, you're not allowed to use any information outside the index of 1 to 4. So therefore you're not allowed to use this index 0, or you're not allowed to use this index 5. You're going to have to make use of the information that's within this problem. And that is your possible set of subproblems. You're going to have 1, 1, 1, 2, 1, 3, 1, 4, then 2, 2, 2, 3, 2, 4, something, and then till 4, 4. Now that's alright, that looks cool. Whatever starts from this and ends at this, and something like that. Now, what about something like this, where you find the from index is greater than the to index, same for here. What's going to be the value of this? What are you going to return when you have an input like this? So what you're going to do is that you're going to return a 0. Now let me tell you why. So if you have a string, if you have a text where you have the from index greater than the to index, what it means is that in that case, you're not going to read this string backwards, right? Because that doesn't make any sense. So what you're going to do instead, you're going to consider this one as an empty string. And if you have an empty string, it does not have anything. And if it does not have anything, how many number of splits are you going to need to make it a palindrome? Is 0, right? Because empty string is a palindrome itself. So if it is a palindrome by itself, the number of splits required is going to be 0. So therefore, return is 0 for these cases. Now, let's talk about the base case that you're going to write in the recursion. So if you have a single character or empty string, in that case, they are palindromes by themselves. So therefore, no split is required and you're going to return a 0. Say for example in here, if you have get splits of 3 to 3, you have only A. So a single character, if you have A, if you read it forward or if you read it backward, is going to be A in either case. So therefore, if it is a palindrome by itself, the number of splits required is 0. On the other hand, if you have something as get splits of 3 to 2, here you have the from index is greater than the to index, and it means that it is an empty string, and therefore empty string is a palindrome, and number of splits required to make it a palindrome is going to be 0. Now, this is a recursive step. So in the recursive step, if you have a text and it is a palindrome by itself, in that case, the splits required is going to be 0. Now, let's understand this concept with the code itself. Now, in this example, you're having the text as this, and you're having a memo, and in this case, we can actually use a map, and in this case, we could have actually used pair of int, but instead I have used an unordered map, and I've used this built key that takes the argument from index and to index and it converts into a key, a unique key that stores the value in this map. The reason I have done it this way is because if you're using a map, it stores the data inside this map in form of a tree. So in Java, it is a tree map. And the problem from that is that it creates the tree and the complexity of searching something or inserting something is going to be O of log n. But instead, if you have an unordered map in Java, it is similar to the hash map. And in this case, what happens is that it creates a hash code, and right at that index, it's going to store this integer information. So therefore, information insertion and information accessing, so in both of the cases, the time complexity is O of 1, which is a constant time complexity. So therefore, using an unordered map or a hash map is always better than using a map or a tree map. All right. Now, this is a base case in the main function where we have the inputs as the from index and the to index. So if you have from index greater than or equal to to index, you're going to return 0, because if it is greater than that, then it is an empty string. And if from index is equal to the to index, then it is a string that has a single character in it. So it is a palindrome by itself, and therefore in both of the cases you're going to return a 0. If it is already present in memo, you're going to search in it, and once you find it, you're going to return it from there. And if it is not already computed, you're going to have it computed and store it in the memo, and it returned at the last. That's fine. Now let's take a look at this part. This is the main recursive steps. So this is the thing. If you find that text at from index and the character present at to index are the same, and the remaining part, what is the remaining part? You increment from index by 1, and you increment the decrement the to index by 1. And you take this function and you pass these two things as parameters. And if you get this to be 0, what it means is that the text starting from index plus 1, ending at to index minus 1 is a palindrome, because you're getting the number of splits required there to make a palindrome is 0. And at the same time, you're finding the text present, the character present at from index and the character present at to index are same as well, then the entire thing is a palindrome. And if it is a palindrome, then you're going to store this as 0, and that's what you're going to return. You're going to return 0 from here. Let's understand it in this case. So let's say in this example, you're having get splits of 1, 5. It means that you're considering this part of the string. Now you're finding that A and A are equal. What it means is that the character present at the from index and the character present at the end index are the same. What you're going to do is that you're going to check for from index plus 1 and to index minus 1, and you're going to compute the get splits for this. And once you have this thing, you see that B and B are same again. So what you do is that you repeat the same thing and you end up getting a single character. And once you get a single character like this case, you return 0 from the base case. And this is what you're doing from here directly. You're not even storing anything in the memo. You don't need to. And once you're doing something like this is returning 0. This is going to return 0 in here. So therefore this is 0. And this is returning 0 in here. So therefore this is 0. So therefore the get splits of 1 to 5 is going to be 0. Now, if the text is not a palindrome, then in that case, what you gotta do? You're gonna have to find the minimum number of splits required to make each part a palindrome. And that you're gonna do by finding the minimum number of splits by splitting it at multiple points in between from index and to index. So what you're going to do is that, let's say if you have get splits of 0 to 4, you're going to have to split this part starting at 0 and ending at 4. What you're going to do is that first you're going to break at this point, and this split gives you this 1. Alright? Then you're going to find the minimum number of splits you require to make this part a palindrome, and which is your get splits of 0, 0. And then you find the minimum number of splits required to make this part a palindrome, which is your get splits 1 to 4. Then you split at this point. So this split contributes 1. You find the minimum number of splits required to make 0 to 1 a palindrome. And then you find the minimum number of splits required to make 2 to 4 this string a palindrome. Alright? Now you do the same thing for here and the same thing from here. And then what you do is that you take the minimum of these things, and what's going to be the get splits value 0 to 4. This is going to be this minimum value exactly itself. And why is that? Because this is the minimum number of splits you require to make the 0 to 4 this substring a palindromic split. Now, if you take a look at the code in here, the way you code this up is that you store this as int max, which is equivalent to infinity. And then what you do, you start this split after counter. You start it from index, and you traverse till to index, and you take the minimum by splitting it at every single point, which is split after. And the way you do it is that you take the minimum of memo of this itself, and you have 1 plus get minimum of the left part plus the get minimum from the right part. And once you have this, you just return. That's it. That's all you do. Now, you just print it out. Now let's try running the code. One. That's right. You're going to require exactly 1 split to make it a palindrome. Why is that? The reason is you have this thing, right? And if you split right in here, you got to see that A is a palindrome by itself, and AB is a palindrome by itself. So you're going to require exactly 1 split to make both of the parts, both of the substrings, a palindromes. And that's why this works. Now, let's try running the Python counterpart as well. Alright, this gives you 1. It works. Alright guys, now let's talk about the time complexity for this solution. If you look at the solution, then you're going to see that the complexity of the recursion in here, this is your recursive part. And in here, you're having a split after parameter that ranges from index to to index. Now, what is the maximum possible value for this range? This is n, because the minimum value the from index can take is 0, and the maximum value this to index can take is n minus 1. And n minus 1 is O of n. So therefore, the number of values this split after variable can take is basically O of n. And if it is O of n, the complexity of this recursion is O of n. So there you go. There you have the complexity of the recursion as O of n. Now, what is the complexity of this dp states, right? How many number of possible dp states you can have? So, how many possible values this from index parameter can take? 0 till n minus 1. And how many possible values can this to index parameter take? 0 till n minus 1. So in either case, you're having O of n and O of n. So the number of possible dynamic programming states you can have in this solution is going to be O of n times O of n, which is O of n squared. So therefore, the overall time complexity is going to be the multiplication of these two, which is O of n cubed. Alright guys, so that's it for this quick video. We come to the end of it, and hope you guys enjoyed this video. The code for this is going to be presented in the GitHub repository. Like this video and subscribe to this channel. If you enjoyed it, share this video with your friends who you feel might find it interesting and useful. And that's it for this video guys. Thanks for watching it, and catch you guys in the next one.